That sucks, but it is what it is. I think now's a good time to start over anyway. I know a little bit more about the game now. So, all right, guys, we are going to switch to launch coverage, man. We have ULA SES-20 and 21 coming in right now. Here, let me get out of that. Okay. I am going to take a break here, and we will go from here. All right. Yeah, Timberborn is fun. It's a good game.
Go at throttle up.
All right, switch this over to science and technology. There we go. Speaking of gigantic L, no, we can't talk about Elon yesterday because I don't want to talk about Elon yesterday because, yeah, no, we can't talk about it, Balaxy. Don't bring it up again. And I hate to be like kind of a dick about this, but I don't want to talk about that. If it doesn't pertain to space, I don't really care. Anybody that talks about it after I've said this and willingly still does that, I'm going to time out. I don't care. I don't care. I don't care. That has nothing to do with space. You want to get that news somewhere else, not here. Okie dokie? Yeah. Don't even say we don't talk about yesterday. Don't even say that. Don't even say that, because that gets people, oh, what do you mean? No, you're inviting the conversation, and if you say stuff like that, don't do that. Just don't do that. Don't douche up my stream with Rule 8 news like that, please. Please don't do that. I'm only asking once. Okie dokie? We cool? We don't need that in here. A 1991 Nissan Figaro or a 1997 Toyota Century? Century. Yeah. Century. All right. Let me get the video up here and we'll go from there. Let me take a look. What should we watch? You know what? I'll just throw on orbital mechanics because that's always a winner. All right. I'll be back in a little bit, dudes. I'm just going to go grab some lunch. And when I get back, we will rocket launch.
When ancient man looked to the heavens for guidance from the gods, he noticed star patterns and began to document their movement across the heavens. The ancients believed that the earth was flat, but around 350 BC, Aristotle proved that the earth was round. Later, about 150 AD, Ptolemy presented the geocentric theory, the belief that the earth is stationary at the center of the universe, with the sun, moon, stars, and planets revolving around it in complex orbits. In the 1500s, Nicholas Copernicus of Poland.
Pause. We need an older video library. This is the 20th time I've seen this. Hey, EJ, do you have other videos that you could watch other than this one? Oh, yeah, sure, man. Here.
On Earth, we move between points which remain fixed relative to each other. But in our solar system, all bodies are in continuous motion. Man has long observed the movements of the sun, the moon, and the planets. He's measured angles and distances, calculated gravitational forces and the shapes of orbits. His vision was limited only by technology. The sharper tools of the 20th century have allowed him to measure the movements of the sun and the planets with reference to other stars in our galaxy. And now he leaves Earth on journeys into space. Eventually, man will set out toward another planet, millions of miles distant. The instruments and techniques of modern science will guide his spacecraft with an accuracy and precision inconceivable to Earth-bound navigators. Though the spacecraft will be traveling at tens of thousands of miles per hour, it will seem to the men on board to be hanging motionless. For them, the stars will be fixed in their positions. There will be no day or night. The receding Earth will not remain behind them, but will be imperceptibly moving ahead. Where they left Earth, there is now only a point in space. If their objective is Mars, for example, they will not be moving directly toward it, but along a curving path, leading them to another point in space beyond the sun. They must arrive at that point at the same time as Mars. Neither they nor the planet can stop and wait. On this trip, an error in injection velocity at Earth of less than 0.1%, that's about 25 miles per hour, will, if it goes uncorrected, cause the craft to miss Mars by over 1/3 of a million miles. The additional propellant and time required to correct so large an error near the end of the trip might be prohibitive. The mission would likely fail. But errors in spaceflight can be corrected during flight because the principles of space navigation are based on the knowledge that the forces involved are constant and predictable. In our solar system, each planet is locked into its orbit around the sun by its particular velocity, the planet's momentum being balanced by the sun's gravitational pull. The inner planets, where the pull is greatest, travel at greater speeds than the outer planets, where the pull is weaker. If a spacecraft is to leave the Earth for another planet, it must increase or decrease the speed imparted to it by the orbiting Earth. Yet, either way, this velocity change is a fraction of the orbital speed of the Earth, 66,000 miles an hour. The velocity imparted by the Earth also puts the spacecraft into the ecliptic plane. That's the plane of the Earth's orbit. It would take the expenditure of considerable energy to get out of that plane. Fortunately, all planets move in planes very close to the ecliptic, and they all orbit in the same direction. Unlike the planets, a spacecraft can change its orbit and its direction because it can change its velocity. When a spacecraft escapes the Earth's gravity in the same direction as the Earth's travel around the sun, its greater momentum around the sun overbalances the sun's pull, throwing the spacecraft outward. But the sun's steady pull eventually slows the craft's outward flight, and here, unless it can boost its speed, it will start to fall inward. On the other hand, if the spacecraft leaves the Earth at the same speed as before, but in a direction opposite to the Earth's travel, it reduces its own velocity around the sun. permitting the sun to pull it gradually inward. But as it falls, it gains speed. This increasing momentum will throw it outward again unless it can reduce its speed. It is a controlled velocity change which alters the course of an orbiting body. In this voyage to Mars, the path the spacecraft should follow has been computed. But putting the craft on exactly the right path cannot be done. Even the most sophisticated launching rocket controls can't avoid small inaccuracies in launching or account for the uncertainties in the orbits of the Earth and planets. There will always be a small error to be corrected. The first correction will compensate for most of this error. A small velocity change made early in the voyage will have a much greater effect than the same change made later. Later corrections will remove residual errors and refine the trajectory of the craft. Fundamental to all navigation is the ability to measure angles. For this, man in space uses a sextant, a device he's been using for over 200 years. With this instrument, the astronaut measures precisely the angle between a planet and a known star. This is recorded along with the exact time of the sighting. This angle defines a cone of position because the angle between the planet and the star could have been sighted from any point on the surface of that cone. But one sighting will not tell him where. The astronaut does know he is near his desired trajectory. His approximate speed, elapsed time, and limits of possible error locate him within a football-shaped volume which navigators call the estimated ellipsoid of position. The space where this ellipsoid intersects the cone establishes his position more closely, in an area where the two coincide. From this, he knows about how far he is from his desired trajectory. Repeated sightings will be made to reduce the amount of uncertainty until the actual trajectory is determined within the allowable limits. If it does not coincide with the desired one, the astronaut must perform a mid-course correction to put his craft on a corrected trajectory. A more precise method for determining position uses 3 sightings from separate known bodies. The 3 cone-shaped surfaces intersect and establish a point of position. Actually, throughout the flight, Earth-based tracking information will be used to correct or supplement onboard navigation, so long as it can supply sufficiently accurate data. But as the spacecraft nears the target position, millions of miles from Earth's tracking stations, the astronaut will have to rely to a much greater extent on his onboard navigational equipment. Any backup information from Earth would take 12 minutes to travel the 134 million miles that separate them. He will determine the exact location of his craft with respect to the planet, using sextant sightings, this time between the target planet and known stars. Now he can calculate the final velocity changes that will put him in a precise parking orbit around the planet. Once determined, these velocity changes are applied, and an orbit around the planet is attained. The astronaut will then use his sextant to track landmarks. This confirms his parking orbit and determines its characteristics, permitting him to plan a descent trajectory. In space operations, man's tools are of utmost importance. They consist of information-gathering devices, both optical and electronic, time-keeping devices, and computers. For manned space navigation, the information-gathering devices are the most varied. They include sextants, or other optical instruments, to measure angles between celestial bodies. Onboard radar and other electronic equipment for position determination and tracking. Earth-based radio and radar for precise distance and velocity measurements. And inertial sensing and measuring equipment to provide a reference frame for positioning the vehicle during mid-course correction and to control the corrective maneuvers. Accurate timekeeping and time recording are done electronically to an accuracy of 1/10,000,000th of a second. The computers, on-board and Earth-based, use both stored information and that furnished them by the measuring and sensing devices. They process at a high speed the large number of involved calculations necessary during all phases of a journey. They can solve in seconds problems which would take an experienced navigator an entire voyage to calculate. The National Aeronautics and Space Administration is engaged in the design and development of these devices and at the procedures and techniques for their use. Studies are underway to determine what navigation functions can best be performed by man in space and which function should be automatic or Earth-based. Automatic on-board star tracking equipment developed for unmanned spacecraft will be available to supplement manned equipment. Deep space tracking equipment and methods are now so accurate that spacecraft can be guided to the moon and the near planets with remarkable accuracy. For example, Mariner 2, on its mission to Venus, traversed 180 million miles of space and was placed within 12,000 miles of its target center. This is like shooting at a moving target from a platform that is moving and rotating at a range of 1 mile and hitting the target 4 1/4 inches from dead center. Later, Ranger 7 hit the moon within 8 miles of its aiming point, 1.5 inches miss at 1 mile. Ranger 9 came closer, impacting only 2 3/4 miles from its target center. Mariner 4 came even closer. Traveling 325 million miles, Mariner 4 swept past Mars within 2,000 miles of its aiming point. And the very first surveyor, Surveyor 1, soft landed on the moon within 9 miles of its target center. A remarkable first attempt. These historic space flights are great technological achievements. They're skillful demonstrations of the reliability and accuracy of Earth-based tracking techniques. But we're still working on the considerable problems of landing on a planet within an accuracy of 10 miles. At the same time, even more effort is being directed toward simplification of both equipment and methods. In manned flight, studies are underway to determine how on-board and Earth-based systems can best work together with the aim of reducing on-board equipment as much as possible. We're constantly improving our knowledge of the planet's masses, their orbits, distances from the sun, so that trajectories can be computed more accurately. We are developing trajectory equations that can be solved by simplified computers, which will still provide navigational data to the degree of reliability needed for manned flight to the planets. Development of new optical techniques for angular measurements are being explored. These may enable a navigator to get accurate information with handheld sextants. Our knowledge is constantly being increased by missions like Gemini. In practicing, we'll gain experience in measuring angles, distances, and relative velocities, and in determining the changes needed to attain specific trajectories. From actual experience, we may be able to make improvements in future systems that we cannot now foresee or predict. Systems development in our most ambitious project to date, the Apollo moon flight, is well underway. The guidance and navigation station aboard the Apollo is equipped with a scanning telescope, a sextant, a digital computer, and an inertial measurement unit. Attitude and guidance controls can be operated directly by the navigator or automatically by the computer at the direction of the navigator. This complete system permits all navigation for the lunar journey to be performed on board, independent of Earth-based tracking or computing facilities if necessary. The navigator will make repeated sightings to confirm his position and trajectory. However, throughout the entire lunar trip, he will have Earth-based tracking information available for use in his own computer. This is how the onboard equipment works. The line of sight of the scanning telescope is fixed to the spacecraft. Looking through this scope, the navigator acquires the Earth and a selected star. He maneuvers the spacecraft until the Earth landmark is centered at 0. Rotation of the telescope reticle till it falls across the star also turns the sextant. He notes the angle of the star and sets the sextant at that angle. Now, looking through the sextant, both images will appear enlarged and superimposed. When they are lined up, he pushes the Mark button. This feeds the precise time and angle information into the computer. The computer also receives Earth-based tracking data, which when combined with the observed data, keeps the navigator informed of his current position and actual trajectory. The navigator instructs the computer to make the necessary trajectory correction. It determines the exact amount and direction of thrust needed to accomplish this correction. The inertial measurement unit furnishes a sense of direction to the computer, enabling the spacecraft to be correctly oriented. The rocket is fired. The inertial measurement unit measures the acceleration, feeding this data to the computer. When the desired speed change is accomplished, the computer cuts off the engine, and now the spacecraft is on its corrected course. More than one correction may be needed. As the moon is approached, sextant readings will be made between known lunar landmarks and appropriate stars to determine the final course correction. Both onboard and Earth-based computers determine independently what maneuver is required to place the Apollo craft into a lunar orbit. The familiar landmark tracking technique is then used to confirm the parking orbit, putting man for the first time in a position to land on extraterrestrial ground. The navigational experience gained in the Apollo program will contribute information needed for trips of greater complexity. For man is not content unless he's pressing himself to the limits of his knowledge or beyond. between points which remain fixed relative to each other. But in our solar system, all bodies are in continuous motion. Man has long observed the movements of the sun, the moon, and the planets. He's measured angles and distances, calculated gravitational forces and the shapes of orbits. His vision was limited only by technology. The sharper tools of the 20th century have allowed him to measure the movements of the sun and the planets with reference to other stars in our galaxy. And now he leaves Earth on journeys into space. Eventually, man will set out toward another planet, millions of miles distant. The instruments and techniques of modern science will guide his spacecraft with an accuracy and precision inconceivable to earthbound navigators. Though the spacecraft will be traveling at tens of thousands of miles per hour, it will seem to the men on board to be hanging motionless. For them, the stars will be fixed in their positions. There will be no day or night. The receding Earth will not remain behind them, but will be imperceptibly moving ahead. Where they left Earth, there is now only a point in space. If their objective is Mars, for example, they will not be moving directly toward it, but along a curving path, leading them to another point in space beyond the sun. They must arrive at that point at the same time as Mars. Neither they nor the planet can stop and wait. On this trip, an error in injection velocity at Earth of less than 0.1%, that's about 25 miles per hour, will, if it goes uncorrected, cause the craft to miss Mars by over 1/3 of a million miles. The additional propellant and time required to correct so large an error near the end of the trip might be prohibitive. The mission would likely fail. But errors in spaceflight can be corrected during flight because the principles of space navigation are based on the knowledge that the forces involved are constant and predictable. In our solar system, each planet is locked into its orbit around the sun by its particular velocity, the planet's momentum being balanced by the sun's gravitational pull. The inner planets, where the pull is greatest, travel at greater speeds than the outer planets, where the pull is weaker. If a spacecraft is to leave the Earth for another planet, it must increase or decrease the speed imparted to it by the orbiting Earth. Yet, either way, this velocity change is a fraction of the orbital speed of the Earth, 66,000 miles an hour. The velocity imparted by the Earth also puts the spacecraft into the ecliptic plane. That's the plane of the Earth's orbit. It would take the expenditure of considerable energy to get out of that plane. Fortunately, all planets move in planes very close to the ecliptic, and they all orbit in the same direction. Unlike the planets, a spacecraft can change its orbit and its direction because it can change its velocity. When a spacecraft escapes the Earth's gravity in the same direction as the Earth's travel around the sun, its greater momentum around the sun overbalances the sun's pull, throwing the spacecraft outward. But the sun's steady pull eventually slows the craft's outward flight, and here, unless it can boost its speed, it will start to fall inward. On the other hand, if the spacecraft leaves the Earth at the same speed as before, but in a direction opposite to the Earth's travel, it reduces its own velocity around the Sun, permitting the Sun to pull it gradually inward. But as it falls, it gains speed. This increasing momentum will throw it outward again unless it can reduce its speed. It is a controlled velocity change which alters the course of an orbiting body. In this voyage to Mars, the path the spacecraft should follow has been computed. But putting the craft on exactly the right path cannot be done. Even the most sophisticated launching rocket controls can't avoid small inaccuracies in launching or account for the uncertainties in the orbits of the Earth and planets. There will always be a small error to be corrected. The first correction will compensate for most of this error. A small velocity change made early in the voyage will have a much greater effect than the same change made later. Later corrections will remove residual errors and refine the trajectory of the craft. Fundamental to all navigation is the ability to measure angles. For this, man in space uses a sextant, a device he's been using for over 200 years. With this instrument, the astronaut measures precisely the angle between a planet and a known star. This is recorded along with the exact time of the sighting. This angle defines a cone of position because the angle between the planet and the star could have been sighted from any point on the surface of that cone. But one sighting will not tell him where. The astronaut does know he is near his desired trajectory. His approximate speed, elapsed time, and limits of possible error locate him within a football-shaped volume which navigators call the estimated ellipsoid of position. The space where this ellipsoid intersects the cone establishes his position more closely, in an area where the two coincide. From this, he knows about how far he is from his desired trajectory. Repeated sightings will be made to reduce the amount of uncertainty until the actual trajectory is determined within the allowable limits. If it does not coincide with the desired one, the astronaut must perform a mid-course correction to put his craft on a corrected trajectory. A more precise method for determining position uses 3 sightings from separate known bodies. The 3 cone-shaped surfaces intersect and establish a point of position. Actually, throughout the flight, Earth-based tracking information will be used to correct or supplement onboard navigation, so long as it can supply sufficiently accurate data. But as the spacecraft nears the target position, millions of miles from Earth's tracking stations, the astronaut will have to rely to a much greater extent on his onboard navigational equipment. Any backup information from Earth would take 12 minutes to travel the 134 million miles that separate them. He will determine the exact location of his craft with respect to the planet, using sextant sightings, this time between the target planet and known stars. Now he can calculate the final velocity changes that will put him in a precise parking orbit around the planet. Once determined, these velocity changes are applied, and an orbit around the planet is attained. The astronaut will then use his sextant to track landmarks. This confirms his parking orbit and determines its characteristics, permitting him to plan a descent trajectory. In all space operations, man's tools are of utmost importance. They consist of information-gathering devices, both optical and electronic, timekeeping devices, and computers. For manned space navigation, the information-gathering devices are the most varied. They include sextants, or other optical instruments, to measure angles between celestial bodies.
Okay.
Onboard radar
All right.
and other electronic equipment.
Okay,
for
dudes.
Position determination and
I'm
tracking.
back. We can switch to that after.
Earth-based radio.
How long until we do that in KSP with Python? It'll happen sooner rather than later. Okay.
Partnership with our shared customer.
Okay. ULA is online. The remnants of the hurricane are coming through, fellas. Yeah. So I did a dumb. Last night so you know how I said we were moving the engine, right? We were moving an engine around yesterday. I left the engine crane in the truck. Tonneau cover won't fit over it with the engine crane in the truck. So I put a tarp over it. And the remnants of the hurricane are coming through. You guys know what a redneck swimming pool is? You guys know what a redneck swimming pool is? That's a redneck swimming pool. So needless to say, I was walking back and I needed to address that. Which is why it took me a second to come back. Oh. I needed a second. The plus side of this, is that, so I had a lot of these in the recycle bin in the shop from, drinking water, right? You probably see me drink these every day. I had a bunch of empty ones. Well, yeah, I did it. I collected a bunch of rainwater. Hey, I needed to get the water out somehow. Might as well do it that way. So I have probably about 20 of these. Easily.
Discovery, go at throttle up.
Easily 20 of those. Yeah. Yeah, easily 20 of those in the in the trash, and I filled all of them up to get all the water out. So, yeah. That hat is not supposed to, yeah, okay. See, that should tell you. Should tell you how wet it is out there. It is raining. It is raining a lot. You did the thing you said you wanted to do years ago. Yeah, that's right, we did. All right, so needless to say, I didn't get to eat my lunch, which is a couple of bags of Cheez-Its. So I'm going to put on the ULA cast.
D180 engine.
And we're going to go from there.
3 Northrop
I'm gonna
Grumman
just
solid
pop off
rocket
for a
boosters,
second.
or SRBs, are attached to the rocket. Atop the booster is the ULA Centaur second stage, powered by an Aerojet Rocketdyne RL-10 C11
Discovery,
engine.
go at throttle up.
The spacecraft are encapsulated inside a protective 5-meter diameter payload fairing, produced by Beyond Gravity in Decatur, Alabama. With production complete, the rocket travels from Alabama to Cape Canaveral on ULA's rocket ship. Once in Florida, a series of events lead to today's countdown. The process begins by lifting the 107-foot booster onto the Mobile Launch Platform, or MLP. Next, we mate the SRBs. Then the Centaur second stage is transported to the pad and lifted into position. Lastly, the payload fairing, with the spacecraft encapsulated inside, is lifted and mated to the Atlas V rocket. Once fully assembled, the launch countdown begins by moving the rocket from the Vertical Integration Facility, or VIF, to the pad. To complete this move, which spans about 1/3 of a mile, the rocket is transported by the MLP. Weighing in at approximately 2 million pounds, the MLP supports the rocket and contains air conditioning, electrical, and commodities lines. Throughout the 20-minute trip, rail cars lead the move, with the payload van providing spacecraft communication and the ground van providing support for the rocket. At the rear of the convoy is an environmental control system, which provides air conditioning to the payload and the rocket. Trackmobiles power the nearly 3 million pound convoy. With the rocket on the pad, the launch team then transitions to fueling and other final preparations.
Atlas V will deliver SES-20 and 21 to a near geosynchronous orbit. Here's how we'll get there.
Generating a combined liftoff thrust of nearly 1.8 million pounds, the RD-180 engine and 3 solid rocket boosters ignite to start ULA's Atlas V rocket on its trip to orbit. Shortly after liftoff, the 1.7 million pound Atlas begins a pitchover to attain the proper flight path while minimizing the dynamic pressure the rocket experiences during flight. Within the first minute of flight, Atlas reaches Mach 1, the speed of sound. Within the next 2 minutes of first stage flight, the Atlas V rocket will jettison all 3 GEM 63 solid rocket boosters and will then more than double its velocity. Once the rocket has climbed above the densest part of Earth's atmosphere, the payload fairing is jettisoned. With the majority of its propellant expended fighting against the force of gravity, the main engine shuts down, followed by release of the booster stage. The rocket now weighs a little more than 10% of what it did at liftoff. To deliver the twin SES-20 and SES-21 satellites to near geosynchronous orbit, Centaur will perform 3 engine burns. Fueled by liquid hydrogen and liquid oxygen, the first burn takes the spacecraft to a LEO parking orbit. Following the first main engine cutoff, Centaur performs a short settled coast and turns to the second burn attitude. The second burn powers the trajectory onto a geosynchronous transfer orbit with a maximum altitude in the geobelt. Following a multi-hour coast, Centaur comes alive for a final burn as it prepares to release the SES satellites into near-circular, near-geosynchronous orbit at an inclination of just 1.9 degrees. Prior to spacecraft separation, Centaur enables a minimum residual shutdown to complete the final burn, utilizing all onboard propellant reserves to achieve the final orbit. This capability allows Centaur to extract every ounce of performance available. More than 5.5 hours after liftoff, Centaur releases SES-20, followed nearly 40 minutes later by the release of SES-21. From their delivery to near geosynchronous orbit, both satellites will require only minimal raising to their final orbital position and rapid activation of commercial broadcast services.
With today's launch, we're remembering teammates who are no longer with us. Let's learn more.
Today's flight is dedicated in memory of Henry Gines and James W. McAnally. For 7 years, Henry Gines served in the Navy as a systems organizational tech and earned the Sea Deployment Ribbon with a Bronze Star for good conduct. Henry then joined McDonnell Douglas's Tycho missile plant in 1987, where he proudly continued his work in national defense by helping with the assembly of Tomahawk cruise missiles,
Discovery,
and
go and
later,
throttle up.
the very successful ACES-2 ejection seat program. Henry later moved on to supporting missions on Delta and Atlas rockets as an accomplished mechanical technician. Outside of work, Henry was passionate about sports, spending his time coaching softball and football teams of all ages. Henry was loyal, dedicated, and always joined his team with a great attitude. He will continue to be missed by his friends and family and his co-workers. Jim McAnally served as president of Martin Marietta Astronautics and later Lockheed Martin during the acquisition of the Atlas and Titan Centaur programs from General Dynamics. Under Jim's leadership, the Atlas and Centaur production lines were moved from San Diego to Denver. International Launch Services was created to sell commercial Atlas rockets. The Atlas V was developed, and his team successfully negotiated the first RD-180 engine. Jim put his heart and soul into his work, and his legacy lives on in today's Atlas V.
We remain in the planned 30-minute hold as we continue towards liftoff. In a few moments, launch conductor Ron McKee will poll the launch team for the final go to pick up the count. 20 engineers and managers are polled for system status and readiness to proceed. This is the final status check for all Atlas vehicle systems, ground systems, spacecraft, and the U.S. Space Force Eastern Range. The vehicle system readiness poll includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as Ron McKee performs the final polling.
Ron?
L minus 7 minutes.
Status check to proceed with terminal count. Atlas systems, propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur systems, propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
Has gas.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
GCQ.
Go.
Operation support.
Chat.
COM. Umbilicals.
Go.
ECS.
What's
Go.
the comm?
Red light
Garble?
monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range coordinator.
Clear to proceed.
Launch director.
You have permission to launch.
Proceeding with the count.
All right, here
ALC
we go.
Verified T0 set for 21:360.
Verified. Discovery. Go at throttle up.
Left roll.
Polling is complete.
Go.
The ULA launch team is go for launch. From T-minus 4 minutes until launch, you'll be listening to Ron McKee and his team performing the final steps in the countdown procedure. Several critical activities occur in the final minutes before launch, including verifying fuel tank and pressure levels in both
Need
the
back up.
Atlas booster
86
and
wants to
Centaur
too.
upper
Nice,
stage,
man.
while also arming the flight termination system. At T-minus 25 seconds, you'll hear Go Atlas, Go Centaur, Go SES. This is the final status check of Atlas, Centaur, and SES readiness.
Medium-sized deal, yeah.
At T-minus 3 seconds, the main engine ignites, followed by ignition of the solid rocket boosters. Then, after seeing Atlas V lift off the launch pad, you'll begin hearing the flight commentator Jesse Gonzalez providing launch vehicle ascent data.
What's the payload? This has SES-20 and 21, two geostationary communication satellites. They're stacked on top of each other, guys. It's pretty cool. Beaver launches, go. Is this the Cape or Vandenberg? Slick 41, Cape. Oh, a little windy down there in Florida today. Got some white caps on the water. There is some cloud cover moving in there. Low clouds. Scattered clouds, though. They should be able to go in this. It depends on the wind, though, guys.
This is Atlas Mission Control at T-minus 4 minutes and holding. We anticipate releasing the hold in just a few moments.
Mark of the time will be T-minus 4 minutes and counting.
Okay, here we go.
3, 2, 1, mark.
4 minutes.
T-minus 3 minutes and 55 seconds.
Ground pyros enabled.
No, not really, Victory. It seems like wind is acceptable.
The countdown clock has resumed, and we are go for launch at 5:36 p.m. Eastern. With liftoff approaching, we're going to raise the volume on our launch team so you can hear the final preps taking place.
That's, I mean, I suppose that's the smallest fairing flying for this rocket, but out of all the Atlas configurations, that is dead center. That's the medium sized. That's the, like, right in the center of the selection of fairings. It is the smallest
T minus
5
3
meter
minutes.
fairing, yeah.
T minus 3 minutes and counting. Op number 057.
Hello?
Securing LO2 topping.
Okay.
250.
Atlas tanks to flight pressure.
Slick 41.
FPS internal.
There you go, Moo. There you go, guy. Yeah. Well, thanks for watching here. Ooh, drone shot. Ooh, hello. Hello. How you doing, Atlas? Oh, please tell me they use this shot when it
159.
launches. Please tell me that shot goes when it
Vehicle internal.
launches.
155.
Launch sequencer start.
Okay.
150. Securing Centaur LH2.
Securing Centaur LO2.
It could be a helo, yeah.
140.
140.
Launch enabled.
137. FPS armed.
T minus 90 seconds. The launch vehicle, payload, ground systems, and eastern range are go for launch.
120. OCU's armed.
FCS count started.
115.
Reduce ECS for launch.
Roger. 110.
Then valves blocked.
T
60
minus
seconds.
1 minute.
T minus 1 minute.
Range green. Go at throttle up.
Range is green, indicating clear skies for launch. 50.
Discovery. Go at throttle up.
seconds.
Stable at step 3.
Stand by for final poll. Final status check here coming.
28.
Verify ECS reduced for launch.
Verify
Environ-
5.
Environmental control systems.
Status check.
Go Atlas. Go Centaur.
Go SES.
Discovery. Go at throttle up.
Final count is, or final status check is cleared. T minus 15, give or take.
T minus 10, 9,
Discovery. Go at
8,
throttle up.
7, 6, 5, 4.
Sound suppressor is on. Good ignition on the RD-180. 3 solid ignition
Liftoff.
and
United
liftoff.
Launch Alliance Atlas V rocket carrying SES
Go, baby,
20
go!
for SES, the leading provider of global content connectivity solutions.
Vehicles pitching over, stand by for rate,
15 seconds into flight.
rate and ascent data here.
Control.
Good shot from the KSC press site there. Vehicle send is looking good thus far.
Coming up on 30 seconds into flight. RD-180 is throttled back as expected. Engine response looks good.
RD-180 is in the
You're
throttle
hearing the
bucket
voice
for
of Jesse
maximum
Gonzalez
dynamic pressure.
providing launch vehicle ascent data.
And 40 seconds into flight. Atlas V is now supersonic.
Vehicle is going faster than the speed of sound.
And the vehicle is now passing through max Q, maximum dynamic pressure.
We have max Q.
And the RD-180 is now throttling back up as expected.
Shot.
Engine
Look at that
response
thing.
continues to look good.
RD-180 is out of the throttle
Passing a
bucket.
minute into flight, continuing to see good SRB chamber pressures. RD-180 pump speed and fuel injector pressures are responding well to demands on the engine.
Depends on the rocket, Black Tracks.
Vehicle is continuing right down the middle of the range track.
Okay, GNC says it's right in the pipe. 5x5. No, it's following the track, which means there's like an imaginary cylinder around the flight path of the rocket, and if the rocket deviates out of this cylinder, right, then, but indicating that it's right down the track means
And we have
very
good
good.
burnout on all 3 SRBs. Standing by for SRB jettison in about 20 seconds.
No, Riv. This is an Atlas 531 launching 2 geostationary communication satellites for SES, SES-20 and SES-21. Should be coming up here on SRB jettison The SRBs have flamed out. They're off. It's just carrying them a little bit outside of the atmosphere so they can separate where there's no air pressure so they can get a clean separation like that. Vehicle is now in closed loop. There's the two
we have good
SRBs.
jettison of all 3 SRBs. And the vehicle has gone to closed loop guidance.
See?
And the RD-180 is throttled down.
You think I'm just saying words,
Engine
don't you?
response continues to look good.
Your boy knows.
About 2 minutes remaining in the boost phase of flight. The vehicle is now 45 miles in altitude, 70 miles downrange, traveling at 5,500 miles per hour.
No, I'm saying magic. Shut up. Wait. No, Dirty, you shut up. Shut your mouth. Shh. No. I'm saying magic or something. Okay. Yeah, everything's looking good here.
Passing 3 minutes into flight, the RD-180 is throttling down again, as expected. Engine response continues to look good.
Damn it, Chief.
And the RCS system is now pressurizing to flight levels.
The reaction control systems, it's a hydrazine catalyst monopropellant system on the Centaur stage. And
about 1 minute remaining in the boost phase of flight.
They've opened up the tank. Oh, some ice coming off. Payload fairing separation. There she goes.
And we've had good indication.
Stand by
of
for
payload fairing
CFLR
jettison and Centaur forward load reactor jettison.
CFLR jettison was good.
And the RD-180 is now throttling up as expected. Engine response continues to look good.
Something like that, Clayton, yeah.
And the RD-180 is now throttling to maintain a constant 4.6 G acceleration limit.
Okay.
And Centaur has begun the boost phase chill down sequence to thermally condition the RL-10 for operation.
RL-10 is being primed for flight, indicating that we're coming up here on...
Standing by for BECO shortly.
BECO, booster engine cutoff. Nice, T-Man. We got an onboard shot looking down
and we've got BECO,
at the top of the
booster
first
engine
stage. Very nice. Stand by for separation. Vent line has come undone there.
And we've had Atlas Centaur separation.
Okay.
And seeing good
expander cycle is
pre-start
primed
on the RL-10.
Should see a good
Standing
start
by
because
for
the
mass
vent
launch
should go
shortly.
away. There it goes.
And we have ignition for the first burn of today's mission. This will be the first of 3 Centaur
RL-10
burns for
TBC
today's
is
mission.
active.
It will last a little
We're
over
good.
7 minutes.
Good staging there from Atlas 5.
RL-10 operating parameters and vehicle body rates are looking good in the first part of the burn. Vehicle continues down the middle of the range track, now at 120 miles in altitude, 500 miles downrange, traveling at about 30,000 miles per hour.
Yeah, the RL-10 is on. You got to remember, its plume is clear. Hydrogen. Hydrolox. Plume is clear. When you saw all this stuff coming out of this thing, guys, it was the propellants. So what they do is they take the hydrogen with the RL-10 and they run the hydrogen through that nozzle. See how the nozzle's all rigid? It has all those channels in it. They run the hydrogen through the nozzle. The nozzle heats up the hydrogen.
This is Atlas Mission Control at T plus 5 minutes 45 seconds.
Give me a second.
We just heard flight commentator Jesse Gonzalez confirm the successful completion of the early phase of today's flight, and all systems continue to operate nominally. Our next event, Centaur main engine cutoff, will occur in about 7 minutes. During this time, I have the pleasure of welcoming ULA's.
All right, real quick. What the hydrogen flowing through the nozzle turns a turbine, and that turns the pumps. RL-10 actually has a gearbox for the liquid oxygen turbine. They're just heating up hydrogen in that nozzle, and that thermal expansion to cool the nozzle is enough to drive a turbine. That turbine is driving the pumps, and the pumps drive the liquid hydrogen and liquid oxygen in there. And what you're seeing is the exhaust from that turbine. And the reason why you saw a bunch of spray coming out is because the hydrogen was, long story short, it was evaporating a little bit. So when the engine turns on, it's nice and clean.
transfer orbit. So the highest point of that orbit will be up at geosynchronous altitude. So after 5 hours, when we're at the top of that elliptical orbit, we will do another Centaur burn. It'll be just over 2 minutes long, and that will essentially circularize the mission. And at that point, we'll be very close to a geosynchronous orbit. We'll take out most of the inclination during that burn as well, and we'll go from about 28 degrees down to about 1.9 degrees of inclination.
Nice.
Following that, we'll separate the satellites. We're going to separate the satellites 40 minutes apart, and that'll be centered around the T plus 6 hour mark. So one about 20 minutes before and 20 minutes after that.
Very nice. And why might a orbit matching Earth's rotation be necessary for these satellites, SES-20 and 21?
Well, that's the advantage of a geosynchronous orbit for many communication satellites. You know, at that altitude, the time that it takes to do one orbit of the Earth matches the time it takes for Earth to rotate once. So from an observer on the surface of the Earth, it looks like the satellite is stationary in the sky. So since you have that fixed relative position, that's very convenient when the satellite needs to provide continuous communication coverage to antennas on the Earth.
Top right, if you want to see what the rocket's doing. This is an animation here. It's an animation that's doing it's a visual representation of what the rocket's doing. But if you want to see the numbers, ULA always puts the numbers in the top right corner. As long as that perigee altitude indicator is
next
going
question
up,
for you.
we're good.
Following separation from ULA Centaur, SES-20 and 21 will be operational fairly quickly. What more can you tell us about that?
Well, they'll be operational very quickly because of that near geosynchronous orbit that we're placing them into. Typical GTO type mission where the spacecraft has to do the orbit raising up to geosynchronous. For a satellite like this, for these two satellites, it would take about 5 to 6 months because they have electric propulsion systems, they're very low thrust systems, so it takes a long time to achieve the final orbit. With this mission today, we're going to put them almost exactly where they need to be for their final operational orbit, so it cuts out most of that orbit raising time, and it'll allow them to get both spacecraft, SES to get both spacecraft operational about 5 months earlier than if we had flown a traditional GTO mission profile.
Very nice. All right, so that leads to our Atlas rocket has quite a legacy
Solar
of
electric
support
propulsion
to commercial
wasn't,
satellite
yeah.
missions. Tell us a little more about some of the missions we've put in orbit.
Sure. So both Atlas and Delta, the rockets we fly at ULA, have been launching commercial satellites since the early 1960s.
That's correct.
In fact, we launched what many consider to be the first true commercial communication satellite, and that was the Telstar mission that Delta launched in July of 1962. And that was such a big deal at the time that it actually inspired a hit song that year. It was recorded by the Tornadoes. That was 1962. After that, for the first few decades of our business, we launched a lot of commercial satellites, but our customers had to work through either NASA or the Air Force at the time.
Okay, so perigee is negative right now because this is indicative of a suborbital trajectory. If that Centaur shut off right now, it would come back down. Yeah, it would burn up in the atmosphere. It's going too fast. It's going too fast right now to come back down in one piece. So basically what the Centaur is doing is, if you notice, the apogee is not really changing very much. And the perigee is changing a lot. Now, okay, first of all, let's define apogee and perigee, okay? Apogee and perigee refer to apoapsis and periapsis around a celestial body. It's one of a kind of a defining thing for how an orbit is kind of understood, I guess. Long story short, apogee is the highest point in the orbit. Perigee is the lowest point in the orbit. If they're different, you're going to be in an elliptical orbit, and if they're the same, you're going to be in a nice circular orbit, right? So if apogee and perigee are the same, you're circularized, right? If not, you're going to be the higher the difference between apogee and perigee, you're increasing another variable for orbital kind of how an orbit is defined. You're increasing another variable there. That variable is eccentricity. Remember I said a second ago that, you know, the bigger the difference between apogee and perigee, the more elliptical or the more egg-shaped your orbit kind of gets. So basically what ULA is looking for is that perigee to go positive right now, and it did. Perigee is positive, so we should see a shutdown here momentarily.
Approaching the end of the first burn of the Centaur second stage. Let's listen in as we approach this next event.
standing by for MECO shortly.
This should stop like right around 200 and change.
And we've had main engine cutoff.
It stopped a little bit.
RL10 shutdown.
I guess that's good enough. But see, check this out. Want to see? Oh, I didn't mean to pause it.
And the RCS is moved up, mainly 100% settling.
Okay, so check this out. The perigee is 163, so they are circularized. But what happened here is once that perigee started going positive, the apogee started springing up like crazy. Okay. In past orbits, this number has been around 200, but this is not a low Earth orbit insertion. So I said it was 200, but it's 163 by 612, which is that's fine for what they're doing. Right now,
participation in today's show. I'm Ryan Gendoli. We'll take another look at liftoff, which occurred at 5:36 p.m. Thanks for joining us.
Oh. It's going to do another insertion burn basically later, so 163 perigee is fine.
T minus 10, 9,
Here's
8,
the replay here.
7, 6, 5, 4, 3. We have ignition. 2, 1. And liftoff of the
They're going to burn
Launch
it
Alliance
AP
Atlas
Morrison.
5 rocket carrying SES-20 and 21 for SES, the leading provider
mission
of global content connectivity solutions.
Look at that thing go.
Passing 15 seconds into flight, PU has gone to closed loop control.
I got him pretty. Well, it looks like ULA stopped the cast right after ascent there, which is fine, but that mission is going to go on for... It's going to go on for a pretty good amount of time. Burn 2 is going to be a T plus 23:51 for 5 minutes. Burn 3, a T plus 5 hour 33:38 for 3 minutes. Yeah, okay. So 23:51 is they're going to let it go out to 600. They're going to let it go out to 600 kilometers. And then they're going to do their transfer, their insertion orbit. That's that 5-minute burn. And then they're going to do a circularization burn with the Centaur at plus 5 hour 33. And that's going to complete the mission. So, yeah, the reason why they stopped the cast is because that, if they'd covered it, it would be going for another 6 hours. So, that was the SES 2021 mission. Everything looks good there. We should get updates through Tori Bruno or ULA through Twitter. Very, 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 very good. All right. Okay. Okay, and it looks like SpaceX has stood down from their Tori Bruno is reporting hot, straight, and nominal. Tori Bruno is the CEO of ULA. It looks like SpaceX has stood down from the Starlink mission that is supposed to be a little bit later today. Let me just double check. How are you beavers today? Oh, they're all dead. Yep. Yeah, they're all dead, by the way. I expanded too fast, killed all of them. Ran out of water. You gonna do some more space or nah? Yeah, we can do a little bit more. Sure, why not? I gotta go check on outside, make sure nothing's flooded. We got the remnants of the hurricane today. Of one of the hurricanes. Ian's coming through Massachusetts right now. Space. All right, what's that? Oh, ABL. Very nice. Thomas, didn't they already fly them into space? Oh, they're going to fly them again when the FAA clears New Shepard for flying. You killed Bucky's, man. Oh, well. Yeah, T-Man, there's a lot of rain outside, dude. There's a lot of rain outside. To say the least. Space news. I got it, Novus. Oops. All right. Here, let me switch us over to space news here. Space and rocket review. All right, cool. You own a UPS and a surge protector, right? You know what, RB? I'm not telling you. I'm not telling you. You should be able to figure that one out yourself. All right, cool. So I guess we'll jump into space news. We'll start off with a video here. I'd rather have the remnants of the hurricane than the actual hurricane going overhead any day. I mean, yeah, me too. Anyway, so that's going to conclude the coverage for ULA. Let's jump into space news. Electron has been pushed to the 7th. Okay, cool. Good to know. Thank you. Let's go over here. Ooh. Very nice launch site. Did they take those pictures with a potato, or? Cool. That's what it looks like outside my house right now. Yo. Yeah, grow up. Yeah, dude. Try to keep it classy. Hey, boys, try to keep it classy for me if you can. I try to be like a teaching environment here. You know what I'm saying? So just keep it classy. Don't get me wrong. I'm not mad. Nobody's upset. I just tell my mods to time everything out, dudes, because you know there are people that watch with their kids and stuff, and you know, just try to keep a nice, classy teaching experience during the day. At night, your boy gets a little rowdy. Send it. Cool. This is a great video. I wonder if they're gonna show the thing. Look at all the planes.
No, you know what? Inside the... I'm trying to... So to show that your ATP is not going to destroy your box, you need...
They're inside of a stage there, you see that?
thought they said the countdown, like, they said 6 minutes, and that was 2:10.
Hello. I don't hate that.
But then I listened again when we got up here, and I was like,
Yeah, that's got it. Okay. I love the interstage. This is ABL Space Systems.
But they're metal. There you go.
Thanks, buddy. Here we go.
Alright, let's love to. Let's go.
Yeah! My guy.
Can I bring it up, Tracer?
Shut up, T-Man. How's it getting up there? How did they? Oh. That's nice. There's the full rocket. That was a cool little little montage video there. That's pretty sweet. So that's coming from ABL Space Systems. That's called the RS-1 Path to Flight, and that's the rocket that they showed at the beginning. Here, let me show you guys. There she is. That's kind of cool. They presented it as a little slideshow. That's pretty neat. I love the interstage. I love it. The interstage is supposed to look like a it's supposed to look redstone. It's supposed to look like a redstone rocket. See? It's supposed to look like dude, it's a throwback. I dig it. I'm so glad they didn't even necessary to add music. What, you don't want them to you don't want this? It kind of works, but no, I like the way they did it too. Nah, Farm, I don't. Not yet. I don't have this thing worked up yet, so let's see. Let's go through. Yeah, dude, that's what it looks like outside right now. It's at my house. So RS1 stands for Redstone 1. I'm not sure, Lazarus. Yeah. Let's see. Let me look through. There's a bunch of cool stuff that we saw in there. I'm kind of just going through it. So right there, that's a heat exchanger for something with a cryo loop. Guy's got an angel's hat on. Plumbing for an engine test. Looks like they were testing. Hello. Oh. Well, it goes from something really small, probably like a power pack or something. I'm not exactly sure what that is. Maybe just a combustion chamber or something. And then it goes to that, which is very nice. All right, kind of now I want to look through all these pictures. Let's see. Second stages. First stage cleaning. That guy's soldering something. Bird. Second stage.
Discovery, go at throttle.
Well, I think I can safely tell you that they're using Jet A, so Carolox. The second stage gets fueled through stage 1, which is neat. That's my idea! Ah, dicks! Edwards. That guy's grinding a stud out of concrete right there with that angle grinder. No shield. I see I see you like to live dangerously, my guy. But he's got some steel toes on, so it shouldn't be a problem. You can see the fuel lines in the interstage here. Yeah, interesting. Interesting. Guys, those look like steelworker suits. Those aren't like scape suits or anything. They're not hazmat either. Those look like thermal. Can I just, if you just give me a moment. Yeah! I like that. You can hear it. You can hear the turbo pump spool up. That's my favorite, man. I love that noise. That's whoosh, and then just the best noise ever. Listen, so, okay, the motor starts to turn on. They start spinning the turbines, and you could hear the power pack starting to move. And then when the power packs, when that kind of power pack noise kind of levels off, then the engine turns on. Ready? Watch. Listen. I love that noise. Yes. What? Zay, you keep saying return of the LR87. What are we talking about here? Okay, so, all right. Now you piqued my curiosity. So ABL Space Systems. Okay, let's see. Now you piqued my damn curiosity. What do you got here? So they have E2 engines in the first stage and then an E2 vacuum engine. Okay. Oh, look at this little guy. Oh, look at this little guy. Cute. Okay, it can use Jet A or RP1. It's using a turbo pump. Open cycle engine, fellas. It looks like there's a tap for film cooling right there on the nozzle. It is a gas generator. Printed nickel alloy. And it makes 12,000 pounds at sea level. Yeah, just straight gas generator. Open cycle gas generator, it looks like with a tap for cooling the nozzle. That's about it. That's about as simple as you can make a cryogenic engine right there. Like, that is absurdly simple. That's simpler than... Actually, nah, it's about as simple. I was about to say it's about as simple as a Merlin engine, but it's actually probably less complicated than that. Cool. I just need to, you know, for science. I like that. I like it. It's pretty good. What else we got in here? Oh, guys are pouring concrete. Reinforced concrete, though. See the rebar lattice? That's the strong stuff. These are test stands here at Mojave. Looks like testing for the E2 engine. Pardon me. That concrete is not cured, guys. Either that or it's just coking from the engine. But also, might not be. Oh no, that's from the sound suppressor. Ah, I see. That's just dirt. Yep, got it. I was gonna say that concrete doesn't look like it's set just yet. When you see concrete that's all different colors like this, that's yeah. And then there's the boneyard in the back. Yeah. Yeah, so I see it right now. The reason why that part is so clean is because they've been spraying water underneath the flume when they're testing the engine. They're spraying water underneath there. The reason why is so it doesn't melt the concrete. Rockets can convect heat like you would not believe. Insulated Connex with a toolbox in it. How much you want to bet they create the whole thing up by the base plate when empty and need no support structure? Yeah, I mean, maybe. I'm gonna look at that again. Wiring. These guys are making the harness for the rocket. See?
Inside the... I'm trying to...
QA.
So to show that you're...
That was avionics testing from what I can
It's
tell.
not going to destroy your box. You need... Again,
So those guys are inside of the first stage. They're doing tank cleaning and testing. Or just tank cleaning. See the COPVs? Helium composite overwrap pressure vessels inside of the stage. Pretty cool. And see, they have HVAC going in there maintaining positive pressure. Because if you're trying, you don't want any contaminants in here. Dust, mold, whatever. You don't want anything other than the fuel going into the rocket engine. If you have contaminants in there, it's called FOD, foreign object debris. FOD kills the rocket. This kills the rocket. Looks like we got a... Oh, the launch frame. Knew you recognized them. They took a picture. Nice. That's the start of a vertical test stand. See the flame deflector? There's first stage, looks like first stage integration testing is going on over there. There's their original 2 test stands. Yeah, they're a lot more coked out after this. See how burnt that concrete is? That's from doing a lot of testing. It depends, RB.
I thought they said the countdown, like they said 6 minutes, and that was 2:10.
Second stage test stand right there. See that? And there's that bucket doing work. I was going to say that second stage engine test stand went kablooey from what I understand, but they wouldn't show it. They wouldn't show that. That test stand exploded. No water? The water's being shot into the flame deflector, dude. Kodiak.
But then I listened again when we got up here and I was like...
There's first stage. They're in an Elon tent. This is up in Kodiak, Alaska. Yeah, I know those heaters. I'm all too familiar with those. Working on the loading dock. There's the interstage right there. It's an ISO grid, aluminum ISO grid. So a couple of things that are dead giveaway. So the ISO grid is triangles. And the fact that it's like this greenish color, that's the anti-corrosion primer for aluminum. Or aluminium, or aluminum as we like to say. So yeah, ISO grid. Like Atlas 5. Atlas 5 is the first one to do that. This is milled aluminum right there. They mill all this stuff out from a big block, and then they put it through a brake and they make the different pieces and then they weld them together.
These are like zip ties, but they're metal. There you go.
Thanks, buddy. Think it's cold there?
Alright, let's love
That guy. You hear what that guy said? Alright, let's launch this snot.
Alright, let's love
Oh my God. Did they rotate that? Oh. So I've only heard ABL for a couple days. What's their story? Okay. What ABL is trying to do, fellas, here, I'll just give you a quick spiel. So Reagan, what ABL is trying to do is basically try to make, it's another try to make spaceflight as low, like costs of spaceflight as low as possible. So what they're basically, what their kind of story is somewhat similar to Astra, only it's not Astra. Astra is trying to make the cost to get into space a lot lower by mass producing simple rockets. ABL is doing the same thing, but ABL is doing it not to the point that Astra was doing it. Astra's rocket is literally made out of like sheet metal and stuff. It's very simple. But even making it out of super simple components, and it's making it out of super simple components ended up making it a little bit harder. That ended up making the rocket a lot harder to make. Interestingly enough. ABL is trying to do what Astra does, but they're going about it their own way. They're going about it their own way with the RS-1 rocket and the E-2 engines. You saw how simple those rocket engines are. They're very, 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 very simple. It's very, very simple. So yeah, they're trying to pioneer low-cost small sat launching by making an absurdly reliable, absurdly simple rocket. I mean, this thing is nothing special. Like, and I don't mean that as a defamatory thing. They're where they're starting with that RS-1 rocket is trying to build something that's very, very easy to make. Very, for a rocket, not as easy as Astra. Astra's, like, those components, from what I understand, were not very high tech. ABL is still like printing engines. They're using milled aluminum iso grids, so it's made out of more aerospace style stuff. But they're trying to come up with ways to like mass produce rockets. That's really what they're trying to do. They're trying to keep it as simple as possible, while still kind of keeping it in the aerospace realm of things. If that makes sense. So they have the ABL's doing the rapid launch stuff too, Thomas. Very nice. So they can launch anywhere, anytime. Their launch pad is modular, which is actually pretty cool.
Let's go.
Still trying to figure out how that thing goes up. Look at the jacking cylinder on the base.
Can I bring it up pressure?
Two going down there, like. Yeah, I see him right. See something right there. Interesting. At the start of those shots before integration. Oh yeah, okay, I see it. Yep, that's how they're doing that. A polar system, huh? Man, that's got to be one strong hydraulic to do that. Hey, Shimoda, thank you for the raid. I appreciate it. Yeah, I see it right there.
Alright, let's launch this.
Alright, let's launch this thing, man. Hell yeah.
Can I bring it up
Yep. No strong back. Interesting. This is Kodiak, Alaska. Yeah, I see it, Aqualix. Yeah, I see it. It's 2 cylinders on either side. Hell yeah. But you can see the cylinder right there. See it? Nice. This is a really awesome video. There's a lot of cool stuff shown in here. Yeah, no strong back. No strong back for that rocket. That's why they're using an ISO grid, guys. They focused on the internal structure of the vehicle. There's no transporter erector from this. You back the rocket right up to it, it locks in, and boom, you're good. Second stage fuels through the first. Yeah, it has to. That's a pretty cool piece of kit. I'm not gonna lie to you. That's pretty cool. I mean, yeah, also, shameless plug for Kodiak Island. Look at that place. The Payload User's Guide has a ton of information. Okay. Okay. Hey, Wood, 35-month resub. Thank you. Okay. Oh. Hello. Yeah. Of course, that's a lot of links. We're never gonna get to all that, man. We will. Just, yeah. I'm trying to figure this stuff out here. Yeah, look at that little guy. Avionics manufacturing bay. Cool. Oh, 2 different sizes of fairings. That's their PAF. Yep. That's the pad. That's it. Yeah. Wow. That's the pad. That's pretty cool. But can you do that in Kerbal? Would a pulley system work in KSP for launch pad infrastructure? If we had a rope? So this is all your fuels. Liquid fuel oxidizer. Helium systems right here. That goes to the container. That container's carrying all the pumps and all the commodity distribution systems. That's the electronics over here. And then you have your launcher, the flame diverter, and the rocket. Man, there's a lot in here for the user guide, man. There's a lot of stuff in here. Interesting. Saxaford Space Center. Yeah. They already have like 80 launches booked already. Why never on the equator? Logistics, mostly. Fluid and electrical. Look at that. Look at how simple that thing is. So they are trying to do, they're in competition with Astra. They're trying to do what Astra's doing. Pretty much the same thing. Only their rocket is a little less complicated, or a little more complicated than Astra's is, but cool. Can I do this one more time? Let me watch this one more time. You were here for launch, but had to leave during the rest. How was orbital insertion? Well, will they hash out one design before moving to an upgrade? I don't know. Everything was fine. Yep. You can follow ULA launch to get the updates on the mission. Huh. Hey. Yep. There's the commodities box. Commodities are left and right here, interestingly enough. And there's their electrical box. It looks like the sides of the container open up, and then you have all your pumping systems right there. That's pretty cool, man. Still one of your favorite pictures that they've shared. Yeah, it's nice. Yeah, see this part that says remove before flight? You got to remove it before flight. It's true. Now, what if you don't remove it before flight? Well, that's not what it said to do. I mean, if you remove it before flight, you're going to lose it. Let me put it to you like that. It's a FOD cover. You know, you probably don't have to, but yeah, I mean, it says to do it, so you should probably do what it says. Read the sign. Lemonade. Read the sign. Yeah, it says it right there. I mean, Watson, sometimes I don't know why I have to explain these things. Come on, can you not read? Like, not you, but it's like... I bet you that plumbing gets simplified. That's actually pretty damn simple, dude, for what it is. Yeah, it's pretty simple. Don't be sheep, leave it on. Oh dear. All right, well, that's a cool video coming from them. That's a cool video coming from them. Sorry. Considering we really haven't seen much, but I'm transferring over the rest of the links here. We do have some pretty cool NASA news you guys might like. Actually, there's a bunch of cool NASA news. Now that I'm looking around, now that I'm seeing these links that you guys have sent. Simple hold down as well, just two pistons pulling down on the release. Yeah, it's like, that's old school, man. Thomas, it's interesting. They seem to be inspired from a lot of old school rockets. as some folks in the chat have said, yeah, from what I can tell, the E2 just looks like a Carolox LR87. It's not the same. It shares no commonality, but it does look very similar. Their hold down mechanisms, very old school. They look like atlases. They look like an old school atlas hold down system. The checker logo, redstone. Yeah, it's supposed to look like a redstone missile. That's cool. That's cool. It seems like they borrowed not necessarily the exact copy, but a bunch of ideas from the early parts of the US space program. I mean, I was just joking about the noise the engine made. Our LR87 is very simple. It's very similar to that, except one big difference. They're using a single turbo shaft. So they have a gas generator hitting a turbine wheel, right? And that turbine wheel is moving kerosene and liquid oxygen. The LR87 was a little bit different, believe it or not. The Aerojet LR87 was the motor that Titan used. It's one of the... Give me a second. It's one of the... It's a very interesting engine. Here's a picture of one. That's actually the Titan 1 that's at Cape Canaveral Air Force Space and Missile Museum. Or Cape Canaveral Space Force Space and Missile Museum. So, it's interesting because if... That's actually two motors. Those are two engines. However, if you put two LR87s together, it's also called an LR87. Yeah, so you could have a singular LR87, or you could have two LR87s, and it's still called an LR87. Now, the LR87 does have two separate shafts for the impellers. What the LR87 does is a gas generator, right? You have a gas generator, that gas generator spinning a turbine. That turbine has a gear on the shaft. And there's a gear, actually how it goes is like this. It has turbine, impeller for the liquid fuel, and then on the top of the turbine there's a gearbox, and that gearbox is going to another shaft, and that shaft has the LOX impeller on it, or oxidizer impeller. This made the LR87 pretty interesting in that gearbox on the top was a dead the gearbox on the top is kind of a dead giveaway, but what is it a dead giveaway to? The dead giveaway is that the LR87 holds the title for one of the only engines that can run off kerosene, hydrazine, and hydrolox. They ran it off everything. LR87s ran Carolox on the Titan 1. They ran hypergolics, so hydrazine, on Titan 2. And they also messed with a hydrogen version of that motor as well, with a hydrolox version. It can do all three of them because of that quick change gearbox. So it's using two shafts. You have the hydrogen, or the liquid fuel one, and then the oxidizer one. Now, why could you run different propellants? Well, the gearbox, like I said, is a dead giveaway. All you got to do is just change the gear ratio to make sure the pumps are moving the right amount of commodities. I've seen the gearbox up close. I hugged one. Pretty straightforward stuff. It looks like a quick change rear end. So quick change rear end is something that allows you to change the final drive ratio on a race car. It literally looks like that. Two shafts. It looks exactly like that. Like the similarity is kind of uncanny, almost as if they got the idea for quick change rear ends from that. But have they run it on all of it at the same time? No, that's never happened. But yeah, that's a quick change. It looks, take away this part, it looks exactly like this. Yeah, kind of weird. The housing, that's almost exact. The housing looks like that. It's kind of strange. Yeah, considering. But yeah, you could just change the gear. You change the gear ratio. You change the gear ratio between the liquid fuel impeller and the oxidizer impeller with that gearbox, and that made it so the LR87 can run off of anything. Now, I don't necessarily think that that's what ABL is doing with the E2 engine. They have a single shaft, so it's not they can't run it off different propellants unless they wanted to go in and change the fluid impeller on the shaft, which is not really what you want to do. You'd have to redesign the entire engine because you're redesigning the power pack. I mean, but it is cool. It seems like there's a lot of stuff from ABL that is kind of past parts of the space program, kind of inspired. Hugging 1A, yep, that's right. What is a good railroad game like old Sid Meier's that isn't too deep for my mother? I'm not sure, Doom. Could you implement it for hydrogen? Just curious. An LR87. It ran on hydrogen. It ran on hydrogen, monomethylhydrazine, and dinitrogen tetroxide, a la the Titan 2, and Carolox. Titan 1. Yeah, all they got to do is just make new gears for it, and you can get the ratios right. Fuel ratios. It's really cool, actually. It's a really smart idea. In fact, I'm kind of waiting for somebody to do that. You know, you have a first stage and you have a second stage, and they have a gearbox. They have a gearbox style drive like that, and then you could just change your seconds, make the same engine, right? Same engine, change the commodities. Use hydrogen in the second stage. You could use the same motor. I mean, with a vacuum optimized nozzle, but you could do it. It's actually really smart. I'm here to remind you of things. Nah, I'll do it at the end of Space News. All right, so Falcon 9 and Dragon. So this is coming from SpaceX. Falcon 9 and Dragon are looking good for tomorrow's crew launch at 12 p.m. Eastern Time. I'm going to be here early for this, fellas. Yeah, we're going to be here early for this coverage. Tomorrow's going to be a nice long stream. The launch is scheduled at noontime Eastern tomorrow. Teams are keeping an eye on the winds alongside the Ascent Corridor. Webcast will go live at 8:35 a.m. Well, I'll see you guys at 8 tomorrow. I'll see you at 8 tomorrow. Targeting later that day at 4:10 p.m. Pacific time for Falcon 9's launch of Starlink from California. Why did they put the first one in Eastern time and the second one in Pacific time, man? Crew 5. Yeah, there's the Crew 5 crew. That's pretty international crew we got going here. We have Koichi Wakata of the Japanese Space Agency. Koichi Wakata is a very, very advanced, like, he's done a lot of stuff in space before. You should read about him. Koichi's done a lot of stuff. He flew on the shuttle program, which is really sweet. Then you have Nicole Mann here. That's her first flight in space. And then Josh Cassada right there. It's his first flight in space. And then Anna Kickna over here is flying on Crew 5 for Roscosmos, which is actually pretty cool. We got a big international crew here, which is pretty sweet. Yeah, because first is East Coast, second is West. Yeah. Yeah, Ilya Anna's flying on it. See? Yeah, and it's Anna's first flight as well. Koichi's flown into space a bunch of times. I actually don't know off the top of my head how many times he's flown, but he has flown a lot. Look at this resume. STS-72, STS-92, STS-119. He went up on 119, back on 127. Soyuz TMA-11, and then SpaceX Crew 5. Guy's flown a lot of missions. 3 shuttle flights. He helped install the on STS-119, I think. Actually, I think it was this one. I think they installed the Japanese illustration of the ISS after. No, that installed the Z1 truss segment and the Z1 truss segment and the pressurized mating adapter 3, PMA 3. And then STS-119, one of these things put up the Kibo module. He was the first ISS commander from Japan. Oh, look at that right there. Look at that guy with the smiling face on, smiling face right there. He's so damn happy to be there with that company. You know what, Mr. President? The proof is in the pudding. Are we going to have pudding after this? That was like 2008. When did this mission launch? 2009. Oh, there we go. He has a lot of pudding to launch up into space there. Yeah, so Koji Wakata has done a lot of cool stuff. It's cool to see him flying again, which is really neat. Set Bill impression to 2x speed. Yeah, if you set it to 2x speed, it sounds like another Bill that I don't want to keep talking about. You understand? So that's the Crew 5 crew. That's scheduled to go to start coverage at 8:30 Eastern time tomorrow. Now, okay, all right. If you're from overseas and 8:30 Eastern time doesn't mean anything to you, take the start time that I usually start at minus 3 hours from that, 3.5 hours. Minus 4 if you want my start time. So take whatever time I start at your local time, minus 4 hours from that. That's when I'm going to be here. Why? Because he constantly talks about pudding. Ilya, Bill constantly... Okay, so this is weird to... Like, if English is your second language, this is going to be hard to explain, I guess. Bill uses a lot of, like, Southern U.S., like, proverbs, right? Like, real old school stuff that people don't really say anymore. So, like, one of the ones he says is the proof is in the pudding, which means kind of the proof is self-evident, I guess. Like, you don't, like, look, there's your proof right there, right? And it's funny hearing him say pudding all over and over again. Colloquialisms, there you go. That's the right word. But I don't think people that speak English as a second language are going to understand what colloquialism means. Oh, bless your heart. He hasn't said that to anybody yet, but... But, yeah, he likes talking about pudding a lot. And he actually talks like this. Anyway, Group 5 is set to go off tomorrow. Coverage will start at 8 a.m. here, and then we'll go from there. So we have something here from Jeff Faust, a thread about that. It's probably from the Flight Readiness Review or the FRR for Crew 5. Jeff Faust is saying that NASA's Steve Stitch, who runs the Commercial Crew Program, says they are working 3 open items for a Crew 5 launch on Wednesday. Issues with the recovery ship to station keep. These are a little rough. Swap out a thrust vector control actuator on a Merlin engine after the static fire. And then addressing a potential leak on the fire extinguisher inside of Dragon. Okay. Weather is good for launch with a 90% probability to go for the ascent on Wednesday. Watching the weather on the ascent corridor because the remnants of Hurricane Ian. Yeah. Good thing my mic is filtering that out today because it's pretty loud. I have the roof insulated and you can still hear the rain, which is good. That's neat. SpaceX's Benji Reed says that none of the 3 issues are showstoppers for a Wednesday launch. They're working to resolve all 3 right now. And an additional thing to mention, given current circumstances, that NASA's ISS manager Joe Montalbano says that NASA is fully staffed in Russia, working closely with the U.S. Embassy on this in light of updated warnings. Oh, yeah. Oh, boy. Oh, boy. Yep. Nope. We don't need to talk about that anymore. Next video. Here. I got you a video from Stennis about the B-2 test stand where they did SLS's green run right there. You liked when you could hear the rain? Oh. Can you hear it now? Riders on the storm, bang ba ding ding ding. Riders on the storm. That's a great song. No mixer and the guitar's in there yet. The guitar is here. The mixer isn't hooked up. If you give this man a ride, sweet family will die. Riders on the storm. There's a killer on the road. All right, movie time. Here, check it out. Video on the B-2 test stand. You guys will like this. The Interstage Simulator
Good morning.
Project.
My name is Nick Nugent. I'm a project engineer here at the NASA Stennis Space Center in Mississippi. We're here on the tarmac of the historic B-2 test stand. The large steel structure behind me is called the Interstage Simulator. It was brought over here on September 21st via barge from the Michoud Assembly Facility after its major structural steel work was completed. The Interstage Simulator will be used for the EUS, the Exploration Upper Stage Green Run that will occur here at Stennis. The Exploration Upper Stage, or EUS, is going to be the Space Launch System's new upper stage. The Exploration Upper Stage sits on top of the core stage, and after the solid rocket boosters are jettisoned and the core stage burn is complete, this takes the service module and the Orion capsule further on its journey to the moon. It's coming here to the Stennis Space Center to go through a series of green run tests. There'll be a series of tests, everything from avionics power up, that will culminate ultimately in a hot fire, just like we did with the core stage for green run. The Interstage Simulator provides an environmental shelter for the lower half of the EUS vehicle. That allows the avionics, the propulsion system, and other sensors inside there to be environmentally protected while it's outside here at Stennis for the green run. The top of the Interstage serves as the thrust takeout, so that's where the thrust is actually transferred from the vehicle back to the test stand. Now that the Interstage Simulator is here at Stennis, the teams on site will finish it. So part of that finishing process is installing all of the piping that goes inside, all of the different tubing and wiring connections that interface to the facility and the rocket, and then finally we will blast and paint it before installing it into the test stand. The Exploration Upper Stage Green Run testing here at Stennis is very important to the NASA mission. As NASA looks to gain a better understanding of the universe, important projects like this need to occur. As we look to make a sustainable presence on the moon and then continue into deep space into Mars, advancing the technology and making the missions occur are very important. Stennis is on the front lines of doing that with our rocket engine testing, our component testing, and then also our stage testing like we did with the core stage green run. It's an exciting time to be here.
Oh boy. You know what I always say, chap? When you start seeing testing equipment being made and test stands being manufactured to test things, you know, that's when you know that it's going to be real. Otherwise, the proof is in the pudding. You remember Apollo 8? I remember eating pudding while watching Apollo 8. Anyway, so they started working on the B-2 test stand, Aperture Science. What the Looks like Cave Johnson's gonna need more moon rocks. Ah! Look! The Borealis! This was a triumph. I'm making a note here. Huge success. Yeah, look at that. Also a really nice picture.
Discovery, go at throttle up.
Stegen 9916 month resub. Thank you. So yeah, there you go. That's the test article for the EUS. That's cool. I mean, if they're moving this thing here, guys, we can't be that far away from the exploration upper stage. The exploration upper stage, what I've been basically saying, should have been built into SLS from the start, but yeah, you know, we won't be too bitter about that. The exploration upper stage is a big Hydrolox upper stage for SLS. It's going to be used in the Block 1B variant. That will increase his SLS's throw out to the moon pretty significantly, pretty much doubling it. Yeah. Actually, it's... Yeah, it's pretty much doubling. It's almost doubling it, but yeah. The Aperture Science logo spun the other way. Okay. Can you post the link? Post your link. My worry is still the LM2 issue. Can't find any updates. The LM2 issue. LM2. You guys wanted the rain. You guys got the rain. Just saying. Oh, ML2. Ordon, they wouldn't be making a test article. They wouldn't be making this test article if they weren't making ML2. ML2, I can... Look, that test article wouldn't exist if the pad... That was my knee. If the pad didn't exist, in some way, shape, or form, that thing wouldn't exist. I mean, unless NASA's completely gone off the deep end, which I don't think that they have. I'm pretty sure they haven't. Pretty sure that hasn't happened. I mean, one could argue that, but people that argue that, we don't like. Yes, they have different opinions than us, right? And, you know, everybody's entitled to their opinion. That doesn't mean we like them. Because look at this. Look at the... Ooh, see that? Doesn't that excite your emotions? Oh, that's gonna be pretty sweet, dude. Does this spark joy in your heart? That sparks joy in mine. That's pretty freaking cool, man. It looks good with a fairing on top as well. Oh, poggers! Yep, I like that. Yep, we should do that. I will say this once, I'll say it again. This is the version of SLS that should have been made out of the box. Hey, Predominant. Predominant, you look at this. Does looking at this make you want to spruck? Skip it up. Give it up. How about a little lightning? There's no lightning, Pythos, I don't think. It's just rain. And now that I said something, there's going to be lightning. It makes me want to invest into transport of some sort. Yeah. Me too. Me too, man. Me too. Actually, hang on a second. Search for EU... fellas? Hey. Oh, look. A stir welding jig. We need interplanetary... You're not going to get any argument from me. A stir welding jig. Gee, I wonder what that's for. EUS panel test weld at the VXC Building 115 at Michoud on February 9th, 2021. Man, that was a long time ago. Oh, look, the jig for it is already made. Oh, yeah. Yeah, that's nice. That's nice. Yep. I want it. I want it. You guys like the raining noise? Oh, that's nice. Hold on. Can we... It's pretty high to alleviate. You were asking me about the Thor... Here, hold on. I got an idea. You were asking me about the Thor missile. How it separates, right? You were asking me about that. Do you still want to know? EUS and chill. Indeed. Any idea on what is a helicopter's loss of tail rotor effectiveness? No, but I saw the Huey video. I'd have to go look at it. How's that sound with the, Wait. I got a better idea. I don't want to set the world on fire. I just want to start a flame in your heart. Yeah. It's hard. That's a hard song to sing, man. It's good. It works with the music. Karaoke streams are my thing. Quit it. I will teach you to sing. I'd rather... I don't want any of that. And that one is you. No other will do. You gotta have the range. You gotta let me warm up, man. Remember, I can do impressions. I can change this. I can change this to sound like something completely different. Look at me, Dr. Zoidberg, homeowner. No. You won't be breaking into song up in here. Alright. Rain noises and EJ reading a rocket propulsion textbook. Any other games tonight? Give me 1 second. Ah, yes. A classic. At precisely 7 a.m. local time on April 12, 1981, the first machine to unite the two engineering concepts of aircraft and spacecraft into a single entity lifted off. It was called the Space Shuttle. Little more than 77 years earlier, a powered flying machine had carried a human occupant through the air for the first time, and it was 20 years to the day since the first man had been sent into space. I'd first encountered the Space Shuttle in 1974 at Palmdale, California, when the manufacturer, known as North American Rockwell, cut metal and began assembling the first orbiter. But I had already lived with it for 8 years as an idea. Works comfort levels are rising. Andy Dufresne came to Shawshank in the summer of 1947 for greasing his wife and the fella she was banging. First night in prison, Andrew Dufresne cost me a lot of money. Can you read it as Chris Farley? Yeah. I'm generally laid in bed and it's nearly midnight. This book is soothing.
Discovery, go and throttle up.
Jean-Jacques. 11 monthly sub. Merci beaucoup. Thanks, man. Alright. So yeah, the EUS is looking to be designed soon. Read it as Hank Hill? Well, I tell you what, I'm gonna start reading about the systems of this dang thing and... Let's see. Let's see if I can find anything here. Life aboard the space shuttle was very different from that experienced by astronauts on the first generations of spacecraft, which were small capsules with little to no room and primitive conditions. I'll tell you what, it's been like getting stuff into a gym locker and then launched into space. I don't know that voice, but you should read everything. In this voice, it's Morgan Freeman. Well, my attempt at one. Any JPEGs in this book? No, I tell you what, they printed some fine aircraft on this book. Right there, see that thing? I'll tell you what, should have made it run off of propane. This is actually a pretty sweet book. This is the Shuttle's Haynes Manual. Oh, God, I still need to make my bookshelf to put all my aerospace books in. I need a bookshelf, like, right there so I can just pull it down. Just got here. Is the EUS being redesigned? No, they started making the test stand for it on the B2 test stand for EUS acceptance testing, which is pretty rad. Anyway, speaking of SLS news, and speaking of the Artemis program, here, check this out. NASA posted this the other day. Gateway is coming together. Following structural welding, the Habitation and Logistics Outpost, or HALO, module will ship from Italy to Gilbert, Arizona, where Northrop Grumman will outfit various components to support future Artemis missions. Guys, we got Gateway flight hardware. Gateway is NASA's space station that's going around the moon. An ortho-grid aluminum friction stir welded design. Or a multi-billion-dollar washing machine. Sure, why not? It looks like this is constructed by Thales Alenia Space in Turin. It looks like the Italians are doing a very, very good job. Bellissimo. Question. It looks like it is coming together very nice. Yes, very, very nice. It's coming together perfect. Bella. Question. Charles, do you want to pass him? Oh, you scruffed your tires. Question. Now you can't pass him. Oh, he got a penalty, but because you scruffed your tires, you are now mathematically eliminated from winning the race. Question. Actually, Ferrari did pretty good you know, if we're gonna talk about that, Ferrari did pretty decent for Singapore, about as good as you could get, because that was a hard race. Singapore's a tough track to drive in the dry, let alone wet. Yeah. Also, what was this I heard about an IROC? I didn't say anything about an IROC, did you? I didn't say nothing about that. Watching this guy, what's up, dude? Yeah, so did McLaren. McLaren did great. Haas was going to do great until George Russell ran Mick off the road and then blamed him for it like a complete and total jive turkey. Anyway, this year was very hot. This year was very hot and super high attrition. It was a good race. It was a good race, straight up. EJ's a Ford guy. He doesn't care about IROCs. Why would I have a picture of one that I was looking at under a cover? Yeah. There was also that. Just on a side note. Yeah, there's also that. That's pretty good. Yeah, it's a pretty cool car. There's a picture of Tough Enough with that car next to it. It's pretty. I had a pretty good weekend. A lot of work, but a pretty good weekend. I owned an IROC. Someone stole the T-tops. That sucks. Because once you take those out, once you take it out, it's never sealing ever again. But they also noted in a podcast that they're designing it with the capacity to, and there's understanding with the international partners that they will use it as a transfer vehicle on future Mars missions. Interesting. EG always listens to you talking about cars. Are you interested in bikes? No me gusta. Kinda sus. Now, do dragsters and space rockets use the same engine? No. No, Casey, no. But what a car engine does and what a rocket engine does is not that far off. They both take fuel and an oxidizer, combine them together, and light a match. The thing with a car is it makes that explosion, and that explosion pushes a piston down, and that piston spins a drive shaft, right? And that drive shaft ends up, with a car through a couple of other magical applications, it finds its way to the wheels, and you accelerate, right? Even a dragster is using that. A rocket engine takes that explosion and then pinches it, and then shoots it out a very, very small nozzle. Well, it's a small nozzle that goes to a big nozzle. But the idea of combustion, deflagration, if that word made no sense, basically explosions, being used to generate work, rocket engine, car engine does the same thing. They do the same thing. Any Hearts of Iron nowadays? Actually, Daddy, I was playing the new expansion. Yeah, I forgot all about that because I played it last week. Yeah, we'll play it again. We are working as Italy, and I have taken over the world. No, well, at least I'm trying. Okay, Elon Musk is buying Twitter. That's neat. That doesn't have anything to do with space, so I don't really want to talk about it. Yeah, that's pretty cool though, I guess. Looks like he's actually going through with it though, so that's kind of neat, I guess. Whoa, wait a minute, hold on, dude, that is absurdly close. The ULA ops leader. Guys, this video might get a little bit loud. This video might get a little loud, so just bear with me here.
Yeah, pitch over already.
Stand by for the rumble. My gird, Gersh burps. To shreds, you say. Can I just one more time? Link, please. Question, link, please. Yeah. Can we just? I'm gonna just give that guy a follow and just.
Yeah, pitch over already.
Wow. Oh. I'm awake. You awake? That SRB crackle. Guys, that's what they sound like up close. It is. It is an experience. You've never heard it sound like that. It sounds like a freight train, a derailing freight train getting hit with like a nuclear blast. It's the weirdest noise ever. The air rips apart. It's so strange. Here, let me. I'm gonna show you guys it one more time. I'll tell you, it's the crackle noise. It's like rolling thunder, but like way louder. I'll tell you, that's normal, right? You can hear the rumble from a good ways away. That noise. You hear that crackle? That crackly noise, man. Now that's a noise. Now that's a noise, boy. I tell you what. Damn. KSB sound mod that displays that. Oh, that's cool. We got a lot more links. Here's the statement for you. I believe you. I believe you. I mean, they said that they've wanted to in the past, so okay. What else do we got, Cripper? Thank you for compiling all these links, by the way. I do appreciate it. All right. How much louder will the 5-segment SRBs be? Forge. Oh, the Hellfish loud. I mean, you probably won't hear the difference. Probably won't be audible, but they'll be loud. They'll be as loud as the space shuttle. Forge, will I cover the Crew 5 launch tomorrow? That's literally the dumbest thing you've ever asked me. Okay. It's literally the dumbest thing you've ever asked me. That's pretty up there. You've asked me a lot of dumb things. Okay. No, yeah, of course, dude. I'll be here at 8. 8 would be. What time do I start where you are, Forge? It's 6 o'clock, right? Do you like space? Question? Yeah, something like that. All right, so around 2, I'll be here. All right, so what else do we got? Oh, here's a picture from Curiosity. Yep, that wheel is getting a little messed up. Interesting, caveman. Someone from Relativity added a full picture of Aeon R injector plate by mistake in the investor PDF. Okay. Alright, well, I mean, considering that Curiosity has been up there, well, shoot, when did that land? 2011? I'd say that wheel is doing pretty good considering the mileage. Speaking of Relativity, hey. Hey. Would you want to see it? You can link it to me. I'm not showing it on stream, dude. I have a very specific code of conduct. What are we talking about? We're talking about spinning, Myth. That's a good trick. We're excited to share the results of our 10th successful flight test on the suborbital accelerator. Each one of us is carrying an unlicensed suborbital accelerator on our back, which included payloads from NASA Technology, Airbus, Cornell. Oh, yes, Cornell. And Outpost Space. That's not a dead pixel. I told you, spinning is a good trick. This is Spin Launch. Spin Launch is trying to pioneer angular momentum accelerated rockets. Basically, that thing spins the thing around, and then they let it go and let it fly. Yeah. And then all they do is just shoot off a second stage. Yeah. Yeah, Forge, that was kind of dumb. Yeah, that's a big no-no. Linked you the video. Oh, de Madure, link a video. Thank you very much, good sir. Alright, let's see. Let's see what we got.
Good morning, everyone.
Good morning, I'm awake, I swear. Ow! Why you do this?
Good morning, everyone, and welcome to Flight Test 10. Today is a really big
Damn it,
milestone
Jan.
for the company. It is the first time that we're flying external partner payloads on our flight vehicle. In fact, we're flying a NASA payload, Cornell University, Outpost Space, and Airbus all on board with us today.
We had over 150 people here from industry, aerospace, satellites, space, government, Department of Defense. And to be able to share this with the world is so incredibly energizing and exciting, and it is such a proud moment for us and for the team that got us here.
Even as I'm starting to explain this, I'm getting chills. This day to me has been amazing on so many different levels. And to be a human and just to arrive today and to see an example of a mega engineered structure that is so different from anything I've ever seen before, it makes me so happy and hopeful.
We were one of the payload partners for Flight Test 10, and so it proves to us that you can use close to off-the-shelf components for launch and also in Spin Launch's environment, even though there's high loads.
1,000 mile an hour. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. There it goes! Good launch!
Obviously, a very impressive
What
sort of
the hell?
capability.
What the
Very
hell?
outside the box thinking, and I saw that throughout everybody we talked to here at Spin Launch.
What
They
the
were
hell?
thinking about non-traditional challenges.
It's been a journey. and today we accomplished our 10th test flight, and it has proven that it is a system that is repeatably reliable. This is not a rocket, and clearly our ability to, in just less than 11 months, perform this many tests and have them all function as planned really is a testament to the nature of the technology.
Yeet! Oh my goodness. What the hell? Really unstable? It's wobbling? No, it's not. Wobbling like that means it's spinning. It'll spin stabilize, Forge. Yeah, a lot of tank shells do that. Like old school artillery pieces launch the shell and they spin the shell, and when it comes out of the barrel, it's doing this, and then it spin stabilizes and locks in. Yeah, exactly, Hellfish. Yeah. What's faster, one spin launch vehicle or one sewer lid? Yeah. They're spinning. It's a good trick. Like, just, I'm kind of wondering what that thing is over there. Oh, it's the casing. Okay. The reason why there's a diaphragm right here, guys, is because the inside of this, where it's spinning, is hyperlooped. It's vacuum in there. Yeah, it's near vacuum, so the thing can spin really fast. That thing is actually remarkably intact. Bingo, Louisa, yeah. I mean, oh, nice dirt bikes. That thing... Dude, like... Yo, that thing went into the ground, man, and it's intact. Can you believe that? Dude. It looks like a bunker buster. It's not often that a launch system is designed around an excavator. Yeah. Yeah, about that. Alright, hang on one second. Gotta open up the door. There we go. It sticks into the ground because it's pointy. Yeah, you noticed that, huh?
Untraditional challenges.
It's been a journey, and today we accomplished our 10th test flight, and it has proven that it is a system that is repeatably reliable. This is not a rocket, and clearly our ability to, in just less than 11 months, perform this many tests and have them all function as planned really is a testament to the nature of the technology.
That's kind of crazy, dude. Already covered it, Bandit. Yeah, we already covered it. Not a single word on how high up it went. No. I found Spin Launch's proof of concept video. That's a trebuchet. Can we just call it a space trebuchet and... Could you make it where it goes through the fabric door so it's super reusable? I'm pretty sure that's what they did, Raised. That's what it looks like, at least. Anyway, interesting update coming from Spin Launch. I wonder if they get any plasma formation when the air suddenly rushes back in after they release the launcher. Maybe a little. Anyway, this next one is coming from Northrop Grumman here. Let's see what Northrop Grumman's up to.
As the leading space company in the world, we take pride in the work we do every day to advance humanity's understanding of the universe. And this includes our Cygnus spacecraft and its critical cargo missions to the International Space Station. Today, we recognize and celebrate the contributions of a true pioneer of spaceflight by naming our next Cygnus spacecraft after Dr. Sally Ride.
Word.
Sally Ride made history as the first American female astronaut serving on the crew of the second flight of Challenger. She was a steadfast advocate for diversity and equality in science, inspiring countless women to pursue STEM careers, including me. And her impact continues to be felt today. She paved the way for future generations to push the boundaries of spaceflight and exploration. On behalf of the entire Northrop Grumman team, we are honored to name our newest Cygnus spacecraft after this remarkable woman, Dr. Sally Ride.
Word. But also, if we that's awesome, and I'm super happy that they're naming it after Sally. Sally's cool. She was cool, really cool. But I noticed something. No, not that one. Guys, I can't prove it, but I'm pretty sure that's the Rogers Commission. Yeah, Bren, you noticed that too, huh? Okay. Okay. Rogers Commission here. Little. I can't spell commission. Yeah. So the Rogers Commission. Here, just. That was the report about Challenger. That was the report about Challenger. I mean, if you look at how kind of upset everybody is in this picture, pretty sure that's the Rogers Commission. I could be wrong though. I could be wrong. I kind of hope I'm wrong, but that looks like Sally Ride was on the Rogers Commission. Not a lot of people know that. She was on it. She was on the accident investigation report that helped figure out like O-rings and wind and all that other stuff with Challenger. Yeah. Well, the DoD is there, Aqualex. Yeah, I'm sure there's an application somewhere. Now do this in Flight Simulator. Yeah. She's saying they got nothing to do with my favorite neighbor. I googled Sally Ride Rogers Commission and that image was one that came up. Oh! Yep, I knew I recognized that picture. Yep. Yep. Okay. I suppose it's not a big deal. I suppose that's not a big deal at all. Okay. Really interesting design you guys came up. What is this? What is this? What do you want? Oh, the Vertifan. Yeah, that thing is cool. Dude, we were all in, man. Can you explain the significance of the Rogers Commission? Sally Ride served on the presidential committee that was established to figure out what the heck happened with Challenger when it exploded. Sally Ride was on that commission. So was Neil Armstrong. Believe it or not. And that picture, I know that picture because I've read a lot about the Rogers Commission and space, what was going on with the space shuttle program at the time. I recognize the picture. She did the tough jobs. Yeah, that was not an easy one. Lord, I'll tell you that. No, I'm pretty sure Northrop Grumman doesn't care. How many people are going to notice that? How many people are going to notice that? You all wouldn't have noticed if it wasn't for me. You all would have never... some of you didn't even know what the Rogers Commission was, so not a lot of people are going to notice. But also... also... yeah, I mean, I suppose it's not, like, bad. You know, she did tough jobs, yeah. You skipped this Artemis News tweet. I know what it is. I watched the movie. You pointed it out. Now we know. Yeah, something to learn. Yeah. Sally Ride was the first American woman in space. Yeah. She flew on Challenger in 1983. It's pretty cool. Pretty cool individual. Anyway. Let's see. In October of 2022, NASA will conduct 2 multi-week field tests near Flagstaff to practice mission scenarios for Artemis astronauts. These analog missions will teach astronauts, engineers, and scientists how to conduct future lunar operations. I just want that. Can I have that? Thiokol is also a Northrop Grumman heritage company. Yeah, that's Joe, you know what? That's a good point, man. Cool. You guys want to go on a camping trip with NASA? I'd do that. You can build one. Yeah, I guess I can. I've been to Flagstaff. Little America. That's a good time. It's like a truck with SPM wheels. Oh, dude, that thing was going to be more than that, Oculus. That thing was... If I'm remembering correctly, that truck has enough onboard life... was planned to have enough onboard life support to be able to be a self-contained mobile habitat for, like, weeks. 2 people could live in that thing on the surface of the moon for long-duration stays had they ended up trying to make it. Nope, it got axed because of Constellation before you ask. Yeah, that was one of the things that went down the tube with functioning prototypes. You know. Outmians. They come here, they no buy what nobody buys. Ugh. They come here, they mess up my store. Hey. All right. All right. Now let's see if NSF has a new Starbase video. I know, Aqualex. I know that you know. I just wanted to mention that because I'm still bitter about it. Not safe for... No. That's a different thing. That's a different thing. Don't be stupid. Ship 24. Moved. All right, let's see what we got here. This video is coming from our buddies over at NASA Spaceflight. Nick and Sweeney took this footage here. Let's see what we got. Upgrades continue on the OLM. Per Elon's last tweet about Starship, he said that they're basically beefing up Booster 7 and they're beefing up this thing to get ready for a launch sometime in November. There's nothing really to say contrary, but also aerospace engineering, so it might take a little bit longer. Ship 26's payload section moved to the robotic welding station. Have you gotten over the GTA 5 defeat? Oh yeah, watching. I was over it within 20 minutes of ending the stream. Doesn't mean it didn't hurt. What is that predominant? Why do you do this to me? Damn it, man. All right, Ship 24. Okay, they went back to looking at the OLM after that. SPMT's moving around. Jester. Not in here, man. Not in here. I'm trying to keep this family friendly, man. Jesus. Oh my god. Deport. Pull the ripcord. No. It's alright, Brahman. Don't worry about it. Keep it classy in here if you can, guys. I understand slip of the tongues or other things from time to time. Run, my vans! Oh, run, my vans! Oh, they're moving her. Oh, hello. Man, that thing looks cool. Look at that thing. Crew 5 is tomorrow, badongles. See, alright, look. I want to just say, look at how nice this truck looks from the back. It looks great. That's the front. Just why? Why? Yeah, I know, Aqualex, right? I still think that looks weird. See, this looks great. That looks really nice. That doesn't. That's the front of that truck. It just looks horrible. Yeah, I'll take it, Thomas. That's fine. It looks cool. Character, the front looks like a Pontiac Aztec. Boys, why don't you go and buy yourself a nice truck like that dang old Ford over there? Oh, no, it don't. What are you talking about? Furious typing. The front looks like an Aztec. It definitely does. The split light. It looks like that. It so does. It looks like an Aztec. Oh, come on. Look. It looks horrible. Nothing more manly than a beard on a truck? What? Why does your truck have beards? What are you doing over there? Why doesn't yours? Because then it looks like a train. Man, remember when we thought that was actually going to launch at some point? Trains are... Chevy propaganda in here. It's not my fault you've been brainwashed. So, small rundown. Ship 24 will have some heat shield repairs done and will be moved on a portable test stand to near the orbital tank farm for a full fueling test. After that, Booster 7 will roll out this Friday for a 33 engine test sometime early next week. Stack the ship on the booster, then a full wet dress, and then launch. Then launch license request. Then launch this year. You've been train washed. I drive a train right now. Trains are cool. Yeah, of course trains are cool. But trains are cool when they're trains, not when cars look like trains, okay? EJ, I come from a country known for conquering 70% of the world. I know my manliness. Oh yeah, how'd that work out for you, Dan? Oh yeah, just curious. Not well. It would have worked better if we had bearded trucks. Wouldn't you call it like, oh, it's a bearded lorry? It's a bearded lorry. Oh, it's nice, it's a bearded lorry. Anyway. Yeah, I know, Aqualex. It's very strange, them lot over there. They're very strange, isn't it? Nice, nice. Kenworth. Very good. Very good. Kessler. Another Kenworth. Ooh, what was that? Was that a Trailblazer? Hold on. Oh, no. Just a Tahoe. Tahoes are cool, though. Freightliner. I don't even see the code I don't even see the Starship anymore. All I see is Freightliner, Chevy, Ford, Kenworth. I know what you're saying right now. I'm thinking the same thing. Why, oh, why didn't we watch the KSC footage? Another Freightliner. Nice truck. Bird. Nice Rivian. Yeah, very good. Mac. Very nice. Starship. I'll take that one. You know, we don't need to have the trucks. We just take one of these. That's fine. That's fine. We can take one of these. Dude, look how big that is. I watch this footage all the time. I still can't. My mind's still like, yeah, that's big. Look at this truck. You know how heavy that damn truck is? Look at all the wheels. The amount of wheels something has is usually a good giveaway as to how heavy it is. Look at this truck. This truck has all the wheels. Okay? It has all the freaking wheels. This is a heavy freaking truck. And it looks like a toy compared to Starship. Yeah, look, the Starship has a lot more wheels under it. That's a good point. Seriously, though, that thing is cool. Look at that. Look at that. It's got wheels right behind the cap. It's cool. X.com is going to come back, Pylum. Calling it now. Bird. You have 6 wheels under you right now. Yeah, well, your mom has 8. Wrecked my vans. I wonder where they're moving it to. But yeah, gee, I'm with you on that one. Me and the boys working on Starship. Near the orbital tank farm for fueling forge? Yeah, okay. Bird. Did anyone notice that Crew 5 has a cosmonaut on the crew roster? They finally allowed, I take? Caveman, on February 25th, 2022, I said that nothing is going to change. I meant that. And surely enough, October 4th, 2022, nothing has changed with the ISS. I don't know what to tell you. I don't know what to tell you, homie. Yeah, that's true, Hibbit. That's a good point. Oh, yeah, Aqualux? Yeah. Yep. The boys at 3 p.m. looking for tiles. Yeah, Aqualux also, the painted sideburns, I hate it. I hate it. They look terrible. I was referring to the demanding schematics thing first. NASA and SpaceX proved that it was okay. I don't know what happened with the schematics, to be honest, but Anna's going to fly tomorrow anyway, so nothing has changed, I guess. Or something has. I'm not sure. I mean, what the... Wait a minute. Wait a minute. Oh! Hey. Dude, I can't look at it. Oh, that's cringe. That's cringe. Vulcan made this in response. What did... I don't like this at all. I don't like this at all. Can we... Here. Revpox posted a video from the VAB. Rev posted a video from the VAB of Atlas going off. Here, enjoy this. We need some eye bleach. No, please, I don't want that. Should hear the rumble. About another 5 seconds. Or now. I love that noise. Well, that was cool. The vest logo. The worm ball. Yeah, worm ball's good. Shape it like an octagon for launches that are expected to scrub at least once. I don't understand that one. Can we just like, let's look at another picture. Let's make sure that's not just the angle. It's not. No. 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 Please, that's part of the second stage. Please tell me the booster's expendable. No, it's part of the second stage. We're good, but oh my goodness. Why? 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 God, it deserves a plasma death. Oh. 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 Yeah, that's just, dude, why? Why? I can't stop. Can we go back to the Starship footage, please? Yeah, she is missing a lot of tiles there. It looks like a birthday cake for an 8-year-old that's into rockets. Oh no. It's crooked, silly. It's crooked. No. Oh, you put a cap on it. Why not also hi? Hey, weather guy, what's going on? Dude. I can't do this, man. What's the status of Artemis? Looking to launch. Actually, I have to go check. I think they said the 27th. Ugh. That'd be pretty cool for me, not gonna lie. A little bit of coking going on here. It's weird, Forge. Yeah, there's not much else in that footage. Farm here, let me just double check. Here you go. Teams at NASA Kennedy have assessed impacts from Hurricane Ian and determined there was no damage to Artemis 1. Good news. NASA will focus on November 12th through the 27th launch period to give employees time for post-storm recovery and identify checkouts for launch. Yep. And I just want to let everybody know that I'm taking this and putting it in my research folder here for research down the road. Lots of activity on the orbital launch mount this morning. Oh, cool. Sweet, sweet. Oh, nope, that's the wrong video. Keeps getting more suntan. It's okay. It looks good. It looks aesthetic. Looks awesome. She's a beast. Okay, this one's coming from Alejandro. So Alex over at NASA Spaceflight. What's this, Forge? Meatball Cricket on that too? I don't know. Falcon 9 rocket for the upcoming Galaxy 33 and 34 satellite launch has just rolled by our Space Coast live cams at KSC. The booster, a very sooty one, should be 1060.14, judging by the soot marks. Oh yeah, Falcon 9 can be moved with a second stage attached horizontally. Just thought I'd let you know. Also, that transporter thing that we saw sitting outside of Hangar X. Well, there you go. The Kometo seemed to be busy. Thomas, how much you want to bet that SpaceX has put more mileage on that Kometo in the last 5 years than NASA did in 30? I'm pretty sure. It's just a shame, because that's what the Kometo was supposed to do with the space shuttle. It was supposed to move it around like that. And about on the frequency of Falcon 9s. That's what they wanted to do with the space shuttle. But no bet. Yeah. All right. Well, that's the Galaxy mission. That's supposed to be going next week. All right. What's Harry got for us here? Let me take a look. NOAA's released aerial imagery of Cape Canaveral and Kennedy Space Center after Hurricane Ian passed over. 39B seems to be pretty intact. 39A seems fine to me. Another angle of 39A. Dude. Oh, wow. Look at this. Oh, dude. Look at all that. They got the fuel. Starting to get the fueling paraphernalia figured out. Got a bit bent. Yeah, right. Is this from a satellite? Yeah. Yeah. I could see the crooked meatball from here. Just kidding. That's pretty damn good for a satellite. What is this? Oh. Track the fuel lines for the new CH farm on the right. Yep, there it is. Momento. Wow. There's The hydrogen purge flame at 39A is still there? Okay. That's the LOX tank over there. And then Falcon 9's RP-1 tanks are those older looking ones right there. Huh. Oh, yeah. Okay, Caveman. Yep, yep. And another angle. Imagine what the classified ones can see. Dude, they could read the text off of a newspaper. Pretty dang sure. Oh, wow. Look at this thing. So waiting on Artemis, it's a farm. Can we do without that today? Can we do without that today? Oh boy. You know what I'm saying, man? I don't need to be reminded about that. Am I right? Oh my god. Feeling better? Yeah, I'm all right, man. I'm okay. We're looking at pictures of the frosty Nougatsis. Percolation pond right there. Is this actually a water tower or is that actually a fuel tank? I can't tell. It looks like it's got double liners. It'd be nice that I not have an Artemis trip. Dude, I'm too tired. I'm too tired. I worked my butt off yesterday. That's cool. These are really awesome pictures. What else does Harry got pictures of in here? Okay. Ooh. LC-48. Great. Slick 41. Wow, that's pretty freaking good. Slick 40. Yeah, and guys, from what I understand, Slick 40 is getting a crew access tower. Yeah. Slick 37. I wish they would use A, but they won't. Guys, I said don't do that. Just don't. Just don't. Just don't. Just let it go. Just let it go, dudes. Please. Please, just let it go. Come on. But where on 40? Dude, if I had to guess, Forge, I'd put it in the same exact spot that it is on ULA's pad. Put it in the same spot as 41. Seriously, right next, like right there. Do we have the space to do that? Let me take a look. Yeah, you could put it right there. Yeah, pretty cool. What else we got in this album? So there's Slick 37. A lot of people don't know that Delta 4's launch complex, Slick 37B, is actually part of, well, Complex 37, and Complex 37 is a twin pad launch complex that was made during the Apollo program. See that diamond right there? That's Slick 37A, and that old diamond right there was the original pad for Slick 37B. And then in the 2000s, they just built this right over it. Yep. Yep. Give me 1 second, dudes. These pics are a nice time capsule compilation for future reference. 20 I don't think is doing anything. '20 is Firefly? Yeah, but I don't think they've done anything here. Also last. I checked when that rumor first went out, and yeah, they can make a 39A size tower there. Cool. Wait, Thomas, what is that in regards to, the 39A size tower? Which pad? I did, Copter, I did see that. The Slick 40 crew access thing. Oh, okay. Okay, yeah. Cool. There's LC-16, so that's relativity right there. Cool. Hangar M. More? Question? Wait a minute. Wait a minute. Thomas, there's more of them. Why would they have more of the... Those are parts of the orbital launch mount, guys. Those are parts to the OLM, the pieces that look like pie cuts. That thing. See this thing right here? Part of that. That's not the one that's going at 39A. The one that's going at 39A is still inside. It's inside of that hangar that's right next to it. See the hangar? Hangar M? It's in there. We know because we saw segments on Google Earth, right? That were stacked here like a year ago, and then they just disappeared. I can only assume that they're going in there, but yeah, now there's more of them. Well, that's the first I'm seeing of that. There's LZ1 and 2 on the former Complex 13. Cool. 12 seen better days. Here's 36. This is New Glenn's pad. Oh, TE parts. Hell yeah. Future video of 37 after Delta. Yeah, fire in the hole! Oh, hey, look, now there's 2 of them! Yeah, there's the SPMT to move it, too. Look at that, man. Man, that's crazy. There's Complex 46. Jeez, great pictures from Harry, dude. Look at that monster. Sound suppressor. I don't think we've seen that before from this angle. We've seen it, but we haven't seen that. Yeah, Forge, I know. It's pretty crazy. Well, I'm sure we'll see more of this on video tomorrow. There's the cap for that thing, but it looks like there's 2 caps. That's vacuum, dude. That's a vacuum sealed. That's a vacuum sealed container, guys. That's the LOX tank. You see how there's a seam right there? It's the LOX tank. There's two caps right here. One for the inner one, one for the outer one. It's a vacuum. It's a giant vacuum sealed thermos. Yeah, that's what that is. Unfreaking believable. We thought that was a water tank, but it's definitely not. Repost, my city decided to localize the Aurora Borealis. It's not a spotlight. We drove under it and there's nothing there. Oh, that's cool. Build the tanks in the farm at Boca, but not Starship size for the inner one. It's built like the tanks at the farm in Boca, but it's not Starship sized. Yeah, maybe they redid the design a little bit. There, dude, I said when SpaceX first started making Roberts Road, I said when they first started making Roberts Road that the way they set up building the orbital launch mount segments was designed to make a lot of launch pads for Starship. Make a lot of them. There we go. Jeez. SpaceX rule number 47. It's never a water tank, unless it is. I was spotted from Austin heading to Florida. Jeez Louise. Crazy. All right, dudes. I think that is enough. So, fellas, here's what's going to happen. Launchpad reusability still hasn't been proven yet. So mass-produce the launch pads? Yeah. Did you see the video about Snoopy as, oh no? We did see this. Yeah, yeah. That's cool. Are you about to rob us? No. Why would I do that? Anyway, guys, that's going to do it for Space News. I would play a game, but I have to get up in the morning. So we did a solid 8 hours today, and we're probably going to end up doing like 16 tomorrow. We have Crew 5 and then Starlink. Yeah, Crew 5 and then Starlink tomorrow. Have a good night. Also, it's a bit loud. Headphone users, just in case. Headphone users, headphone users, headphone users. Just in case. What is a bit loud? Oh, yeah. Yeah, that's a good note to leave on. So yeah, I don't want to stop the stream early, but also I'm going to get some sleep tonight. And yeah, here, headphone users. I love how they cropped out the copyright. Gee, I wonder whose footage this is. Lovely. You forgot the thing. What thing? That's a pretty awesome shot of Concorde. Apparently do the thing. Okay. The thing you were going to ask them about. You guys ever been to a Turkish prison? Now that didn't suck. No, I like that. How did you know? Remo, we'll figure this out tomorrow, and I'm not just saying that. I actually thought of something. So, yeah. We gotta talk about that. So, yeah. All right, guys. So I'll see you guys tomorrow at 8. I'll see you guys tomorrow at 8, and let's see who we can raid. I have one more thing that I want to show you. I have one more thing I want to show you. One more thing. It's Formula 1. So if you don't care about Formula 1, then check it here. Yeah, while you guys are looking at that, I'll see who we can go over and raid. Shenru's playing F1 manager. Let's go see what Shen's up to.